Okay, so good morning students. Today we are to discuss why a crystal do not have five-fold or more than five-fold symmetry. Okay, you know that suppose we have a crystal, we have seen in symmetry operation that symmetry operation is an action which leave the crystal invariant. Okay, we will make use of this thing here. We will make use of this concept here. The symmetry operation is an action that leave the crystal invariant. Okay, so in place of crystal you can write the lattice arrangement of particles. Okay class, so if the crystal remain invariant after an action, then you can use another action of your choice. I want to say, suppose we will operate two symmetry operation. One is rotation, and then translation. Okay class, so this will be a compound symmetric operation because you are making use of two, and after application of rotation then you will apply translation and the crystal must remain invariant. Okay class, so for this we will see you can use rotation in either direction, clockwise or anti-clockwise direction. Okay, now see, for example, we have a kind of arrangement of particles. Okay, and for the sake of simplicity we will take it to be the arrangement such that the unit cells are of square type. You know that in square the particles are present at a distance a. Okay, so here let I represent the distance between these two lattice point by t, and another distance, this distance it will be t. Okay, here is another particle and one more particle is present here. It is also at a distance t. This distance is t. Again this is also t distance. So here other particles are also present here in both directions. So this is the arrangement of the particle. Now because this is square type and I rotate it by some angle, then the lattice arrangement must not change. So this is the arrangement of particles. Now I will rub this thing. Okay, we know that here the phi rotation must be equal to 90 degree, but we are taking a general case. Okay, so here I will take this lattice point to be a center and I rotate the whole arrangement by some angle, either in clockwise direction or anti-clockwise direction. So to solve it, I will take, this is point A, this is B, this is C, and this is D, and I rotate it by some angle phi. So you see, after rotation, the direction of arrangement will change. Now this is the direction, and if you rotate the crystal about this axis, which is passing through this lattice point B and perpendicular to this plane, then this point will shift at this point. Okay, so it will shift at this point. Okay, and here, if the crystal remain invariant, then there must be a lattice point here. Okay, so let the rotation is phi, and what must be this distance is t, and you are rotating it by phi angle, then what must be this distance a dash b, it is equal to t. So this is the thing. So here the distance a dash b, this is equal to t. Okay, now come to another point, C point. If again we rotate this initial arrangement of particles by some angle phi in anti-clockwise direction, it will repeat the crystal. Okay, let after rotation of phi in anti-clockwise direction, okay class, then this must be the direction. This is the direction initially. Now after rotation, we are rotating this whole arrangement by taking C to be the center and about an axis which is perpendicular to the plane, and you rotate it like this. Then what will happen? This particle D will go here. So this will be the position of the particle D, and I assume it D dash. Now this distance is T. So this distance C D dash, here C D dash, this is equal to again T. Okay, now think of these 2 points A dash and D dash. If these are 2 lattice points, after application of rotation symmetry operation, then these must be connected by translation operation. Okay, and this A dash D dash, A dash D dash, it must be equal to m times of the primitive vector. So this is the primitive vector t in this case. So it must be m times of t. You know that if we have a unit cell, if we have a primitive unit cell where vector A and vector B, these are primitive vectors, and if you have some another point, okay, let this point is this is O point, this is A point, and this is B point, let this point is C, okay, and it is a lattice point in the crystal lattice, then vector OC, it can be found in terms of the primitive vector A and B. So I can write it n1 times of let vector A and n2 times of vector B. So come to this point. Here we have shown the arrangement of particle along one dimension. So initially the particles are arranged in horizontal direction. After rotation, these particles A dash and D dash, these are again in the same direction. Okay, so this translation vector must be m times of t. You can see it here. You can see this thing here. You have 2 directions where particles are arranged along B direction. So you can draw as many directions, lines here as you want, and another direction of arrangement is this. So if you complete the lattice, this point will be here. If you complete the lattice, then this will be the arrangement. And if you take any point here, then it will be, let this is A dash, so it will be twice of A. It will be twice of A. If you take any point along the direction of B, it will be some integral multiple of B. In the same way, this direction of arrangement A dash, D dash and A, D, these are parallel to each other. So arrangement of particles will be at a distance which is integral multiple of T. T is the primitive translation vector in this horizontal direction. That's why I am writing A dash D dash to be m times of T. For more clarification, you can see my previous lectures. So here if you see this geometrically, then what will be, so this I have taken from definition of translation vector, and now I will check it geometrically. Geometrically I will find what is A dash D dash. Here A dash D dash, this is equal to find it, I will draw perpendicular from B point on A dash D dash. So the perpendicular will be this one. In the same way, again I will draw perpendicular from C on A dash D dash. So these are perpendiculars. Okay. So if you find the component of A dash B along the direction of arrangement, that is A dash D dash, then it will be, this will be T cos phi or not. In the same way, this distance will be T cos phi. Okay, now come to this point. These are perpendiculars and these are directions. A dash D dash is parallel to A D. So you can see BC is T. So this distance is T. Let I take this point to be B dash and this point to be C dash. So this distance, this will be T. So if you have a clear picture of translation vector and the primitive vectors, this is very simple topic. Okay, you need not to cram anything. So A dash D dash, from geometry you can see this is T cos phi. So twice of T cos phi plus T. So I can write it, this is 2 T cos phi plus translation vector, primitive translation vector, that is T. Okay class. So now see, the definition says that A dash D dash along the same direction must be integral multiple of the primitive translation vector along that direction. Okay, so this is from the crystal, okay, periodic arrangement of the particles, and this is you have obtained from geometry. So if you compare these two equations, you will get the condition. Okay, the condition, now come to here. So you have used two symmetry operations here. One is the rotation and another is the translation. Okay, so here comparing both, let I take this equation to be 1 and this is equation 2, and from 1 and 2 you will get 2 times of T cos phi plus T, this is equal to m times of T. Okay class, एक बार ओल्ड कर. So class, if you solve it then you will see from in this equation t is on both sides, you can cancel it, and finally you will get cos phi, this is equal to m minus 1 divided by 2. Okay, so this is the condition which restrict the allowed value of phi. Okay, only those values of phi are permissible which obey the rotational symmetry and translation symmetry simultaneously, others are restricted. So here you can see that the value of cos phi, it is less than or equal to 1 and greater than equal to minus 1. So from here you can see what are the allowed value of m and what are the allowed rotations. Okay, pause kar do sir. Now from these two things we can see why phi-fold symmetry do not exist. And okay, and I have told you that symmetry which are greater than 6, those are also not permissible. Okay, we will check it out from this equation. Okay, so here we have cos phi, this is equal to m minus 1 by 2. Okay, I will start it from m equal to, if I put here m equal to 2, then see what is the value, what value you will get, it will be minus half, that is permissible. If I put it suppose minus 2, then you will see it is minus 2, minus 1, minus 3 by 2, so this value is not allowed. Okay, why? Because it gives you the value of cos phi less than minus 1. See, let us check it. So for this value you have cos phi, this is equal to minus 2 minus 1 by 2, that is minus 3 by 2, and this is less than minus 1, which is the lowest allowed value for cos phi. So we cannot take the value of m to be minus 2. In the same way you can check the value of m minus 1. Okay class, and if you find the cos phi here, it will be minus 1 minus 1, put the value of m to be minus 1, minus 1 minus 1 minus 2 divided by 2, so it will give you minus 1, and cos phi to be minus 1, this is allowed. So the value of m to be minus 1, this is allowed. In the same way you can check for m equal to 0, and then m equal to 1, and then m equal to 2. Now see, for m equal to, what is the value? For m equal to 2, the value of cos phi, this will be equal to 2 minus 1 by 2, so this is half, so this is allowed. And if you take m is equal to 3, then the cos phi will be equal to minus 3 minus 1. Okay, you see here I have taken minus, so this is m equal to 3, and if you put it, then you will get 2 by 2, then it is the uppermost value for cos phi. Okay, so all values are within the limit, mean to say if you take m is equal to 4, it will give you cos phi which is greater than 1, which is not allowed. So class, you can see here how many values are there which is allowed, 1, 2, 3, 4, 5. Okay, and corresponding to these things, if you find the value of angle for these, then it will give you the rotation, the angle up to which you can rotate about an axis. Okay, now come to the value of phi. Here if I write, I have less time to finish this lecture. I am writing the allowed value of phi. Here you see m equal to minus 1, this is allowed, and for m equal to minus 1, the value of cos phi, this is minus 1. So the here the angle becomes pi. And for this m equal to 0, the cos phi will become, put 0 here, and you will get it to be minus half, and then cos phi for m equal to 1, it will be 1 minus 1, 0, 0 by 2, 0, and you will get it to be 0. And okay class, so see, if you put the value of m corresponding values, then you will get the value of cos phi to be minus half, 0 and half, and cos phi is minus half at 120 degree. Okay class, so this is 120 degree. You can write it in terms of pi also, and this pi is 180 degree. Okay class, and here cos phi, this is 0, so cos phi is 0 for 90 degree, or you can write it pi by 2, and here cos phi, this is half, it is at 60 degree, and this is pi by 3. And next, that is cos phi equal to 1, this is at 0 degree, so you can take it 0 degree or 0 pi, है ना, 0 times of pi, और 0 ही आ जाएगा. And then or you can write it 2 pi, you can write it 2 pi. Okay class, so these are the allowed rotations. Okay, after which translation is also obeyed. So these are the allowed rotations, and here you will see, if you see the arrangement of particles with respect to these arrangements, then you will see that here the linear arrangement. एक बार pause करना sir. Okay class, so if you change them, how many times of 2 pi these are, then you can write them like this. Then pi by 2, it will be 2 pi by 4, and then here it will be 2 pi by 6, and then it will be 2 pi by 1. So this is the integer which tell you about the allowed rotation. Okay class, you have seen the general formula in rotation, that the angle 2 pi, it is integral multiple of phi. So if you rearrange this, this is 2 pi by n. So this is the factor which tell you how many folds, symmetry and axis can have when you apply the rotation symmetry operation. So here you can see the allowed value of n, that is 1. Okay, then you can see 2, and then you have 3, then you have 4, and then you have 6. So class, 5 is not there, 5 is not there, so 5-fold symmetry is not allowed. So this is the end of the lecture. Thank you class.